Hey, I have the keys to unlock Pocket Ronnie.
We're going to be talking about similar shapes. The one thing that I want to remind you is that similar means the same shape but not the same size. This is the symbol we use for similar. It is not congruent. Remember, congruent is this symbol right there. Congruent means exactly the same. Similar means the same shape but not the same size. This is the symbol for similar. Let's jump down to these two triangles, these two blue triangles. I have a smaller triangle and a larger triangle. These triangles are similar. They are the same shape, but they are not the same size. This smaller triangle is a 30, 60, 90, and so is the larger one. When I blow a triangle up, when I enlarge it, I'm only changing the length of the sides. I do not change the angles. That is important to know in similar shapes. So in similar shapes, you can see that the angles are the same. If I take this triangle, which is the same shape as this one, and I enlarge it, I never change the angles. So it is important to know that the angles are the same. And in a similar triangle, let's just say I took out the 60. If I knew this angle and I knew this angle, then I can determine my third angle because all triangles have 180 degrees in them. So in similar triangles, you only have to prove two angles are congruent. This 90 degrees is congruent to this 90 degrees. This 30 degrees is congruent to this 30 degrees. So to prove that triangles are similar, I only have to prove two angles are congruent in order to show that they are similar. Again, because when we enlarge a triangle, we are only changing the length of the sides, we are not changing the angles. Okay, now let's go up to a problem. This is on 27C. This is the top picture on that page. So we have these two triangles right here. We have the smaller one, and then we blew it up to have the larger one, FJK. In what you're trying to prove, it's important, look at your triangle so you know which triangles you're looking at. We're trying to prove that FGH, the smaller triangle, FGH, is similar to FJK, the larger triangle, FJK. Again, to prove triangles are similar, the symbol right here, we only need to prove two angles are congruent to each other. Now look at angle look at the given. We are told that line segment GH is perpendicular to FJ. So GH is perpendicular to FJ. That tells me that that angle is perpendicular. JK is perpendicular to FJ. So I'm told that that angle is perpendicular. That angle is 90 degrees. That's a right angle. So now I know that this angle is congruent to this angle. So I have to look in the picture at one more thing that I know in the picture. This angle right here is shared by both triangles. In the small triangle, GFH. In the large triangle, JFK. This is with the reflexive property because the angle is shared by both triangles. And now that I have proved that two angles are congruent within these triangles, I can say they're similar. So off to the side, I write AA. There's only one postulate we use to prove triangles similar, and it's AA. That's the only postulate. To prove triangles congruent, we had 4 different postulates, but in proving triangles similar, we only have one postulate. So now we're ready to make the statements. So we start with our givens. GH is perpendicular to FJ, that was given. JK is perpendicular to FJ, that was given. Now we need to make statements about two angles being congruent, okay? These right angles are going to be congruent to each other. So FGH, angle FGH, that is the right angle in the small triangle, FGH, is congruent to the right angle in the large triangle, which is FJK. For the reason, I can just put right angles are congruent. We'll just call 1, 2, 3, 4. So that was an angle. That had to do with an angle. So then I can state that the angle that they share is congruent. So I'm going to start with the small triangle, GFH. It doesn't matter which triangle you start with. It's congruent to the angle in the large triangle, JFK. Angle. And again, the reason is that that's reflexive. Now that I've stated that two angles are congruent, I can make the statement that one triangle is similar to the other, because if we know two angles in a triangle, we can figure out the third angle, because triangles have 180 degrees. The only reason you will ever have two triangles are similar is because of angle, angle. I've proved that two angles are congruent. Okay, let's jump down here to a problems on 27D. We have, in our given, we are told that AE is parallel to DC. AE is parallel to DC. When we have parallel lines, what do we look for? Alternate interior angles. We have two sets of alternate interior angles. We have this angle right there and that angle, or we have this one and that one. We also have vertical angles. So in this picture, we can prove we know that all three angles are congruent, and we can prove that. But to say that they are similar, we only have to use two of them. So I'm going to erase this one, and I'm just going to use the two that I have drawn there. Because to show that triangles are similar, I only have to have AA, which is two angles. So now I'll start with my statements and reasons. So we start with our given. AE is parallel to DC. How do we know that? It is given. Okay, from the given information, we created alternate interior angles. So I will state that. EAB, so angle EAB is congruent to, if I start with E here, I should start with C here, because C corresponds to E. CDB. Angle CDB. Why? Alternate interior angles. Okay, that was a statement for one angle. Okay, just off to the side. Right over here, that was an angle. So now I need to make a statement about my vertical angles. ABE, angle ABE is congruent. If I start with A here, D corresponds with that, DBC, angle DBC. Why are those congruent? Because they're vertical angles. This is just my symbol for angles, in case you're confused. That's an angle symbol. Now, that was a statement about an angle. So since I have made a statement about two angles being congruent, I can now state that the two triangles are similar. So triangle AEB is similar to triangle DCB. Be careful not to put the symbol for congruent right here. Use the symbol for similar. And those are similar because angle postulate, that is the only postulate we have to prove triangles similar. Okay, we are still looking at similar shapes, and now we're going to calculate the length of the sides of similar shapes. Right here I have a smaller triangle, and then I have a larger triangle. The reason I know that they are similar, when you have similar triangles, you only have to have two angles congruent to know that they are similar. I have a right angle here and I have a right angle here. Okay, so that's one angle. Then they tell me in the picture that this angle is congruent to this angle. These markings are important because it shows me that I have two angles that are congruent, and if I know two angles in a triangle, I can calculate the third angle. So therefore I know that this larger triangle is similar to this smaller one. This larger one has just been blown up, enlarged, proportionate to the smaller one. These are proportional. That's important to know because it helps you to set up a ratio to calculate. Since this larger triangle has just been blown up a certain proportion, this side would be similar to this side. This side is proportionally larger by the same amount that this side is proportionally larger to this side. So to calculate these, you just set up a ratio. Ratio is a fancy word for fraction. So we're going to set up a fraction. So I'm going to set up a fraction for one side to the other side. If I start with my smaller triangle here, I'm going to say 5. This 5 is similar to this side over here of x. So I'm going to set up a fraction to say this side to this side is equal. If I start with a smaller triangle in the numerator, then I've got to start with the smaller triangle in the numerator again. And then this side is similar to this side. So again, if all my numerators should be all my smaller triangles, or should at least be the same. All smallers in the numerator, all larger triangle information is in the denominator. So when you have a fraction set equal to a fraction, you cross multiply. 5 times 30 goes to one side of your equal sign. Then you do this times this to your other side, 10x. Now this just becomes algebra. Divide both sides by 10 to solve for x. And you see x equals 15. So this side would be 15. And that makes logical sense because if you look at the hypotenuse, this hypotenuse is 3 times larger than this one. So this side has to also be 3 times larger than the smaller one. They won't all be so easy to logically figure out like this one, but you can at least see that this triangle is 3 times larger than this one. Sometimes the shapes might be only 1.5 times larger. That's not as easy to do in our brain, so this is why you need to know how to do it mathematically and showing by your work. That was 27B15. Now let's jump to 27A17. You can use the same principle on rectangles. It doesn't always have to be triangles. It just needs to be similar shapes. So in our picture, we are told that the two rectangles are similar. So basically, this larger triangle has just been blown up by the same proportion on all sides as this rectangle. So we set up a ratio. If I want to start with this side of my smaller triangle, I can say x is similar to 24. If I start with my smaller triangle in the rectangle in the numerator, then I've got to start with the smaller rectangle in the numerator on the other side. So I'll start with 10 here. 10 is similar to this side over here of 15. Again, it doesn't matter which shape you start with as long as you put the same thing in the numerator on both sides. Here, both my numerators were the small one. Here, both denominators were the large one. It doesn't matter which one you start with as long as you are consistent. So we cross multiply 15x, cross multiply that equals 240. Divide both sides by 15. X equals 16. So that means that this side would have been 16. Okay, let's jump down to 27B15. Okay, you have a similar triangle. We know that because there's these two right angles, and then this angle up here at top is shared by both triangles. That angle right there is shared. So these angles are congruent, then they share this angle, which I know two of the angles. That's how I know that they are similar. The important thing to know in this one, you have this small triangle with the sides of 5 and then 10. And then we only know this information down here about the larger one, that this is x. So I need to know the whole side of this large triangle. This side would be 5 plus x. Okay, don't just say the large triangle side is 5 or x, but it's 5 plus x. That is the length of this whole side of my large triangle. So I set up a ratio of my small triangle. I'm going to start with my small triangle of 5. So that this side is similar to the whole long side of my large triangle. So it'll be 5 over 5 plus x. If I start with my small triangle in the numerator for the first one, I've got to start with the small triangle on the other fraction. So that would be 10 is similar to this side down here. Now I cross multiply. So I'm going to jump over here. Oh, I was going to write 5 times 16. Just let me write. 5 times 16 is 80. And then for over here, I need to say 10 times 5 plus x. So it is important to know that this 10 has to be distributed. So now I have 80 is 50 plus 10x. Get my whole numbers together, so subtract my 50 to both sides. So now I've got 30 equals 10x. Let me jump over here. 30 equals 10x. Divide both sides by 10. So x equals 3. So in other words, this length right here is 3, which means the whole length of that large triangle right there would be 5 plus 3, which would be 8. But they're just trying to get you to solve for x. They didn't ask you what is the length of this whole side, but we can see that that side would be 8.